Good morning, students. I hope you are all in online. Good morning, everyone. I request all of you please join immediately. So, because our scheduled timing 9:30 to 10:30, I request everyone so please join fast. By then we can start our class. I request all of you please mute your audio. So by that my voice will be clear. Thank you, Ansha Reddy. Good morning. Navin Reddy, good morning.
Very good morning, sir.
Good morning. Good morning. So who else? Total 5 participants. Four people have entered the waiting room for this. Good. Come on, guys. Come fast. Good morning, Shiva. Good morning, Mohan. Good morning, Nitin. Harini, good morning. Sarojini, good morning. Good morning, everyone. I request all of you please mute your audio. So by that it will be clear what I'm discussing, right? So please try to put some name on your Zoom application, right? So by that I can find you with your name. So 10 participants. Come on, guys. It's already 9:33. So you people should not be late in online because no need to travel to many places, right? I request all of you to please join immediately. So we'll start session exactly by 9:35 at least. Nitin, good morning. So immediately, yeah. So once everyone join today's session, so then I will share my screen so that we can start our today's session. Connect mode 4. Rahul Verma, good morning. Come fast, guys. 1 minute left. Good morning, Mohan. So students, good morning. Come soon, guys. Only 13 students. Mithun, can I start, Mithun? Mithun and Harini. Where is Mithun? A few more join. Mithun, I have unmuted your voice. Mithun, can I start the session or shall I wait for 2 to 3 minutes?
Oh, 5 minutes wait చేయండి సార్.
Wait చేద్దామా? Okay. Then we'll start by 9:40 then. Okay.
సరే సార్.
Okay, right. I will mute you. Okay, we'll start by exactly 9:40. Okay. Without information.
స్టార్ట్ చేయండి.
Okay. I request all students to please be, unmute. I mean, mute your audio. See, if you're not muting your audio, I will allow all participants to, mute by myself. There is an option called allow participants to unmute themselves. Okay. I won't allow you to, yeah. So you are unmuted yourself, no issue. So what I did is I already muted all you guys. So while entering into this class itself. Okay. So as a request from your class representative, we'll start session by 9:40. Okay, so till now 15 participants. See, from past 1 week, I'm giving online classes on the design of skill structures, which have started from module 1, from introduction of skill structures, right? See, in the time being, even you can revise your content, okay, revise your skill structure, basic fundamentals and all. So once time come to the 4th module, so by that you can also join and you can cover, we can complete our syllabus, so which is the 4th and 5th module, which was left for the second mid examination, right? See, any questions you can chat here. I'm always there to, answer your questions. My schedule was like this. Every day from 10:30 to 12:30, I'm giving the Facebook live on the design of skill structures. So where the students are attending from different places of Andhra and Telangana, from different engineering colleges, right? So all these classes are recorded in my Facebook, right? You can have a look and just you can revise all your content, right? And just few more ready, join. So 1 minute left. So immediately once everyone joins, so by that I can I can share my screen. So by that we can start our session today. See, wake up, guys! It's already 9:40. So many of are still sleepy, I think. So it's not a holiday time. See, wherever you go, at least our e-learning classes will follow. Okay. So that's how Malaredi Engineering College.
కొందరికి కనెక్ట్ అవ్వట్లేదంట.
సారీ,
కొందరికి కనెక్ట్ అవ్వట్లేదంట సార్.
ఎందుకు? మీ అందరు వచ్చారు కదా. రైట్ పాస్వర్డ్, యూజర్ నేమ్ పాస్వర్డ్ ఏదైతే ప్రాపర్ గా ఉందో అది టైప్ చేస్తే అందరికీ వస్తుంది కదా. ఆల్రెడీ 20 participants are in live. Okay, anyway, this video will be recorded, right? Indu is joining now. Let's see. మిథున్
Yes, sir.
ఏమైంది ఇంకా మిగతా వాళ్ళు? I think 19 participants are in the meeting.
20, sir.
20, yeah? Right, okay. So what shall I proceed or?
చేయండి సార్, ఇంకా టైం అవుతుంది.
Right, okay, we'll start then. In between, if anyone comes, by that I can join them, right?
Okay.
Okay, I'm muting you, Mithun. Right.
Okay.
Okay, guys, good morning, everyone. So I think we had a very good platform where I can interact through online like this. So today I would like to explain you on introduction to bridge engineering. So which is also one of the important course related to our skill structures. Okay, I'm sharing my screen now. Right. See, bridge engineering is one of the important course where many engineering colleges kept that particular course as an professional elective. So being we are having a plenty core subjects. So even the bridge engineering is also one of the important core subjects. But for the you know there is a huge academical gap. So in that way, bridge engineering was in professional elective. If you opt this subject, it will be very useful because nowadays all your smart cities uh, is developing in terms of infrastructure wise. Okay, so when we can call it as a smart city, so when it is having a proper transportation between places, so definitely it's gonna give a good infrastructure facility, so which is going to cover the lead and the distances, right? So here, coming to transportation point of view, providing a good infrastructure in terms of transportation. So definitely bridges plays a vital role in terms of flyovers, metros, viaducts, right? Um, I mean cable stayed suspension bridges, overhanging bridges, pedestrian walks, right? Head over bridges, okay, railway over bridges, river over bridges. So these are all comes into uh, like into a good infrastructure facilities, so which makes a city into a smart city. Okay, so that's how it plays a vital role. So in that point of view, I would like to share this PPT, so which gives a information towards the bridge engineering, right? Okay, so let's start the section. See, the learning objectives which I would like to share today. So through this particular course, we can gain a comprehensive understanding of bridge loading, right? And we can develop it's going to develop a critical appreciation and a comprehensive understanding of the methods which are idealized in the structural engineering, and you can even analyze the bridge structure. Okay, so this is how we can have this particular course, and to develop a critical awareness of bridge inspections and assessment. So by having these principles of bridge engineering, even you will be having that awareness how to do the inspection to the bridges and how to assess the you know uh, uh, bridge structures and the bar bending schedule, rebarring of the bridges, and the structural elements of the constructions and all. Okay, yeah, 5 students are entering into waiting room, right? Guys, please be fast, right? We already started the session. One second, then. I'm inviting the Vamsi Krishna Chaudhary, Dasari, Nani. They have come fast, guys. So they are waiting for my request. Yeah, so these are the learning objectives. Rahul, come fast, Rahul. Yeah. So in this today's lecture, is someone writing on the screen. Guys, so please don't do that. Someone writing on the screen which is going to disturb my lecture. I request please don't do that, guys. It is going to obstruct my screen. Mithun, is this fine? Is someone writing on the screen? I request all of you please mute your audio so that it will be easy for me to deliver the lecture and I won't get any disturbance from you guys. If anyone want to question me, you can question on your own. Okay. If someone's still not yet muted, I'm getting bit disturbance from you guys. Guys, please mute your audio. Yeah. Okay. Okay. So in the today's lecture, we'll have about definition on bridge engineering. So we'll have a bridge definition and what are the different types of the bridges available, bridge components, aesthetic in bridge design, and we will have the selection criteria of the bridge type. On what base we are going to have the selection of bridges. And finally, we will have a quiz question. Okay. So through that, our lecture is going to be finished. See, what do you mean bridge? How you define a bridge? So bridge is a structure so which covers the gap, isn't it? And so generally, a bridge carries a load uh, or railway crossings, and even in natural streams or even artificial obstacles. So the bridge is a structure which covers the gap, and it is going to act as a media, so which covers the which laid on the obstacle. So such as the river, canal, and even the other railways or other roads. So that is how bridge is going to cover a gap. And so bridge is a structure which is corresponding to the heaviest responsibility, so which is going to carry a free flow of transport also. So in that way, bridge is going to play a vital role in terms of transportation. So such as in case of communication, also or gaps of different obstacles like valleys and gorges. So that is how bridge is going to play a vital role in terms of transportation, right? And let's see what are the different key elements in the bridges. So the key elements in the bridges is something like structure. So which are the structures for transportation. So here you can see the beauty can be expressed in terms of structural efficiency and simplicity and repetition of the bridge. So you can see the different types of bridges over here. Sorry guys, I think PPT is getting stuck nowadays. Right. See the different key elements in the bridges. So one is a substructure, the other one is a superstructure. Right. So what are the elements comes under the substructure? foundations comes under substructure, pier, and abutment, right? So I think you can see the abutment over here. So this is your abutment. So we'll have a two abutments on either side of the bridge, right? And the piers in between the abutment. And the superstructure, any structure above the bearing is called a superstructure. So here, where is the bearing? So this is the bearing. So bearing is a media which transfers load from superstructure to substructure. So by that, your bearing won't come under any structure. Why? Because bearing is acting like a media to transfer the load from superstructure to substructure. And like deck comes under the superstructure, railing comes under the superstructure, crash barriers, and even the wearing surface where the vehicles pass on the road. So that wearing surface also comes under the superstructure, right? Yeah. See, practical pictures also you can see. So there is the roadway deck, abutment on both sides of the bridge, and so this is a superstructure. So this is a substructure, and this is what an abutment. Okay. So parallel to this abutment, you can see the embankment of the soil. So this is what an embankment, right? So in the bottom line of the picture also, you can see the same. And see the right side picture. So you can see a bearing, so which is transferring load from superstructure to substructure. So where you will have a cap beam like this. So this is called a pier cap. It can also be called as a pier cap. And this is called a piers. And this is called, is someone writing on the screen, guys? So please don't do that. So please try to concentrate on the lecture. Okay. And this is called a pile cap. So below that, you might have a pile or you might have a raft. So if you have a raft below the ground, it will call as a raft cap. Okay. And see the bridge planning, how the bridge planning is done. So bridge basically planned based on the traffic studies. So based on the hydrotechnical studies and the geotechnical studies, environmental considerations, and different alternatives for bridge types, because someone should always think what are the alternatives there to provide a bridge at that particular location. And economic feasibility also is very important, and the bridge selection and detailed design is also very important. So this is how a bridge usually is planned. See, all streams of civil engineering, all specialized in civil engineering will comes into bridge structures. See, traffic studies will be done by transportation people. Hydrotechnical studies will be done by hydrological engineering people, geotechnical engineering, environmental engineering, and main structural engineering be a part of this. See, this is how all different specializations come together to have this bridge planning. Okay, so that is how the consolidation work takes place in the bridge planning, right? So here you can see, so very important. Yeah. See, you can classify the bridges based on the span. So here, a short span bridge is always in between 6 to 30 meters, right? A medium span bridge is nothing but a bridge is having a span of 30 to 100 meters. What do you mean span? Span is nothing but distance between two supports. Okay. So here, the example where you are seeing here, you can see a bridge which is supporting on the abutment side of it. There is no pier in between. So this is called a span, right? Short span bridges lies in between 6 to 30 meters in span. Medium span 30 to 100 meters. Long span greater than 100 meters, right? A bridges which are having less than 6 meters will be treated as a culvert, and the span greater than 6 meters are treated as a bridges. So all our culverts will be having a span less than 6 meters. Either it may be a box culvert or a pipe culvert or a single cell or double cell box culverts. So in that way, culvert is defined as having a span less than 6 meters. Okay, so in that way, the bridges are classified based on the span also. So you can see the materials which are used for constructing the bridges. So here the material steel. If you use steel, it will be a steel bridge. Concrete, it's an RCC bridge. Timber, it's a wooden bridge. Hybrid stone or brick, FRP material. So that is how you can have a bridge based on the type of materials. So the other one is usage. Based on the usage, you can call a bridge names. Based on the pedestrian, it can be called as a pedestrian walk, pedestrian bridge, highway bridge, railway bridge, river over bridges, so like that. Based on the span, you can classify the bridges as short span bridge, medium span bridge, and long span bridge. And coming into a structural form, the bridges are classified based on the structural form. So if the bridge is having only a slab without having a girder or any beam, so by that it's called as a slab bridge. So there will be a girder bridge, truss bridge, arch bridges, suspension bridges, cable stayed suspension bridges. These are all comes under the structural form. Okay, right. See the material and fabrication. So here the materials like we use, as I mentioned, masonry, we can use timber, we can use naked timber bridges, RCC, pre-stressed concrete bridges to have a long spans. Steel you can use, and composites also you can make use to have a bridge. What do you mean composite? It's a combination of steel with concrete. Cannot your rebarring steel, so you can make use of steel sections with the concrete where we can make a composite, composite structure. And coming to the fabrication, so the fabrication can be done in the form of a pre-casting bridges and cast in place where the bridge construction takes place at site. And there is a pre-tensioned bridges also, like post-tensioned bridges, prefabricated bridges, and rivet bridges. So where the bridge is going to be a permanent structure, and bolted structure like the steel and timber. So that is how, based on the fabrication, your bridges are classified, and based on the materials also, you can have a different type of bridges. And coming to highways, see these are the examples of the highway bridges, right? So this is how the highway bridges looks like. Right, and see the next one. And these are the, sorry. So this is the pedestrian bridge. So you can see the pedestrian walk bridges like this. Okay, so these are the few examples of the pedestrian bridges and railway bridges. Railway bridges. Okay. So here you can see the steel railway bridge. At the bottom line, you can see this masonry stone arch bridge, right? Masonry stone arch bridge. So one second, let me close this. Coming automatically, I will make it mostly. Yeah. So basic types of bridges is based on structural form. So the structural form in terms of arch. So you can see the arch action like this. Okay. So this is how the arch bridges looks like. Beam bridge. So there will be a beam, so which is resting, which is supporting your deck. Okay. So that is called as a beam bridge. Cantilever bridge, right? We can see the cantilever bridge at Rameshwaram. So which is the cantilever steel cantilever bridge. Truss bridges also will be there. So here you can see the truss bridge. cable stayed bridge. So this is the cable stayed bridge. And suspension bridges where it is suspended with the help of a tension member, which we call as a string. So let's see the different types of bridges. Okay. Types of bridges like arch bridge. How you define an arch bridge? Arch bridges are one of the oldest types of bridges, and we can have a great natural strength for that particular arch action. So instead of pushing straight down, the weight of an arch bridge is carried outward along the curve of the arch to the support at ends. So that is how the arch action takes place. Okay, from the crown portion, the load will transfer to the support in a form of an arch action, right? So, and next see the supports, or these supports are called the abutments. So where the load transfers to the foundation. In arch actions, loads will transfer to the abutments right away, which carries the load and keep the ends of the bridges from the spreading load. That is how the arch bridges basically looks like, and where it's gonna transfer the load. And if you see the based upon types of structural arrangements, and your bridges are arranged based on eye girder bridge, plate girder bridge, truss girder bridge, and suspension bridge. Okay, see, basically your bridges are classified into different types. So all these types are based upon, based upon the different categories, or I can say different types of functionalities. The first one is bridges will be classified based on the type of structural arrangement. How you arrange, the structure, it is all based on its application. So let's see eye girder bridge. So eye girder bridge, it comes to the your steel structures. So where I can make use of eye steel structural element as a girder, right? In plate girder bridge, so definitely you are going to study this plate girder as your fourth module in steel structures. So where you will come to know how to design the plate girder. And the truss girder bridge, so it will be a composite structure which is having a different truss and strut and the tie members in that. Okay, and the suspension bridge. So this is how, based on the type of structural arrangements, the bridges are classified, right? And the next one, it is based on the structural action or nature of suspension, I mean, nature of superstructure action. So based on the action also, your bridges are classified. So you can see the first one, simply supported span bridge. So where it is supporting on two supports. Continuous span bridge, where it is supporting on number of supporting actions. Like if your bridge is having a different piers, so it can call it as a continuous span bridge. A cantilever bridge where one end is fixed, the other end is fixed. Okay, so where it can able to movable also. So when you have a pin support at one end, okay, that is how. If you have a fixed support at one end, it can't rotate. So it can also be called as a cantilever bridge. And the arch bridge, so it is based on the arch action, and the rigid frame bridge. So these are the different types of bridges available based on the structural action or nature of superstructure action, right? So let's see the next one. It's based on the type of connections again. Say as we are well known about the different types of connections. So here you can see even bridges are also classified based on the types of connections. Riveted bridges, welded bridges, bolted bridges, and pinned bridges. See, I think you can see all kind of connections over here, where riveted bridges is a temporary bridge, welded bridge is a permanent bridge, bolted bridge is a temporary bridge, and pinned bridge is a temporary bridge. And rivet and bolting both are permanent, and bolting and pinned are temporary. So that is how bridges are also classified based on the connection, right? And see, it's based on floor action. So how your deck is supposed to subjected to load. It's based on the floor action. Also, your bridges are classified. So one is the deck type bridge. So if you have a deck alone, it can fall as a deck type bridge. And through type bridge. So through type in the sense, so where it is allowing from one place to other place. Okay, so the bridge which is having an access from one place to other place. Okay, so that kind of structure also can be called as a through type bridge and semi-through type bridge or a pony type bridge. So I will show you some pictures on how this semi-through type and pony type bridges are looks like. And double deck bridge is also there. Okay, so which is used in rail cum road bridges. So this is how double deck. So I think the way how you see the double decker bridges. So at one deck you can find a you know I mean the road transportation takes place. On the other deck there will be a railway deck will be there. So in that way it's called as a double deck bridge, which will accommodate both roads and railways like that. Okay, so in that way your bridges are classified based on the floor action. And let's see the next one. It is next one is based upon the movement of structural parts. So how the part of the structure or element of the structure moves. Based upon that also your bridges are classified. One is a fixed or permanent bridge. So by that there won't be any movement in the bridges. And the other one is a movable bridge, right? So the bridge where it can move vertically up and down and where it can move horizontally also. Okay, so I think you have seen lot of pedestrian bridges where it can move up and down. So there are a few pedestrian bridges where it can move even horizontally also. So that is how there is a movable bridge which can be called as a structural part of the bridge, which makes into a different types of the bridges, right? And the next one is based upon the purpose of bridge. So what is the purpose? So if you want to have a bridge which can accommodate a road transport, so that is called as a road bridge. So if there is if you want to accommodate for railways, it will be a railway bridge. For pedestrians, it will be a pedestrian bridge. So again, purpose is also very important while constructing the bridges. So based on the purpose, your bridges are also being classified, right? And based upon the loading. So here, Indian Road Congress uh, given a clear picture on different types of loads where your bridges are going to be classified. Okay, so there is a, apart from this, there is a one important loading, which is a 70-hour loading. So where your bridges are supposed to design for military tankers. Okay, so that's how it's all based on the loading. For 70-hour loading, the maximum capacity, the maximum load coming from your military tanker will be around 1,000 tons. Okay, so that is how, sorry, 100 tons. So that is how your uh, bridges are classified based upon the loadings also, which is IRC class A loading, IRC class A loading bridge is there, IRC class B bridge is also, three loading is also there. So for B bridge loading, so you will go for the temporary bridges. For class A, class AA, so where loads will be more, your bridges will be a permanent structure bridges, right? So that is how your bridges are classified based upon the loading. And coming to the next one, based upon the span length, and again you can see your bridges are classified based upon the span. As I told you, culvert, when the span is less than 6 meters, we should call it as a culvert. And the span which is in between 6 to 30 meters, we should call it as a minor bridge. And the major bridge which is having a span more than 30 meters. See, whatever the bridges you have seen, like cable stayed bridges, suspension bridges, we use them for the major bridges where it can accommodate a large spans. Okay, in that way, bridges are classified based upon the span length also, right? So this is how the bridges are basically classified. It is not just like a road bridge where it can be classified not based on the simple function. So it based on the span, it based on the function, it based on the usage, it based on the application. So like that, bridges are classified on the different factors. So now I would like to show you some pictures on each bridge. See here you can see the arch bridge. So where you can see the arch action of the bridge. Yeah. So this is your arch bridge. So you can see the how load transfers from arches to abutments, right? Forces along the arch, and this is the road deck. This load transfers to the arches, and it carries the forces and it transfers to the abutments. So this is how the arch bridges look. And see the masonry archway. So this is the masonry archway. So basically, this masonry archway will have a span in and around 3 to 15 meters. So you can see the probably first category of bridge which is to be involved in olden days. And basically, these bridges are aesthetically superior to the slab bridges. So even the aesthetical look of these bridges also will be very nice. And the arch-shaped slab supports on two opposite walls. So it is not opposite, it's an opposite wall, and it can adopt earlier for small 3 to 15 meters of its masonry action. So that is how even you can extend it up to 519 to 305 meters in concrete, which has been built in the world. So even for half kilometer of length also, bridges can accommodate the transportation. And you can see the beam bridge here. So basically, you all know the beam action. So the bottommost layers will be subjected to tension, and the topmost layers will be subjected to compression. So that is how the beam action takes place for the beam bridges. So basically, beam bridges, when something pushes down on the beam, so definitely beam bends, and if the top edge is pushed together, and if the bottom edge is pulled apart. So that is how the beam action takes place. Okay. Not only in a single span bridge, even in the continuous bridges also the action will be same, right? So which is across two or more spans. So let's see the next one. So which is a beam bridge again. So I think you all seen these kind of bridges. There are two piers and two abutments. So not abutment. There are four piers here. So and this is called pile base, and this is called pile. So basically, piles will be below the ground. So that is how the structure usually looks like, and this is the deck. And this is called pipe culvert. So where we call these culvert where spans is less than 6 meters. You all seen these kind of culverts, right? So the culvert usually will be with a pipe, or sometimes it will be with a single cell and double cell pipe culvert. Okay. And basically these culverts are used for suitable for a cross drainage flow. So that is how people provide pipes for the cross drainage flow. And these single cell and double cell box culverts usually you are seen in your outer ring road. It is for the passage for the road transportation. They have these single cell and double cell box culverts they provide. Okay, and this is the next one, and you can see the same over here. So which is a hydraulically short conduct which conveys the steam flow through a roadway embankment, and it's a flow obstruction, other type of a flow obstruction. And again, there is a slab bridge here, so which is a simple type of construction, and which can accommodate for small bridges and culverts, and it can have a span of around 10 to 20 meters. And plate girder bridge. So this is what we are talking about, which is related to your steel structure. See, this is something like a plate girder which is having more in depth. So you can see a huge girder over here, which is made up of an eye structural element. So this eye section was prepared with the help of plates, so which formed into an eye section. So such a big member, so which is having more web depth, so which is to be stiffened with the help of a web stiffness. So you can see there are multiple stiffness which are provided at what I mean, which are provided vertically. They are called web stiffness to control web buckling due to shear. Okay, so that is how web is going to be supported with the help of web stiffness throughout its longitudinal length, right? So basically, these plate girder bridges can accommodate a span of around 10 to 60 meters, and for the continuous bridge means it can go up to 1/4 of a kilometer, 250 meters in the continuous construction. You can go with the plate girder bridge. And truss bridge. So I think you can see truss bridge over here. So the span 30 to 375 meters in simply supported case, you can accommodate a truss bridge. See, till around 400 meters without any support, you can have a truss bridge. So here each individual member is subjected to tension and compression. There are a lot of bracings on the top and the bracings even on the lateral sides of the section. And even you can see the I section which is supporting for the deck. Okay, so this is how the truss bridge looks like. If you are good enough in designing steel sections, even you can able to design the truss bridges with that steel knowledge. So all these elements which are seen here, they're all you know laterally supported in the form of the lacing, right? So you can see the lacing for these sections over here, right? So this is how the truss bridge looks like. And the next one is suspension bridge. You all seen this, right? So there is a big confusion in between suspension bridge and cable stayed bridge. Both are different. Suspension bridge is different. Cable stayed suspension bridges. Cable stayed bridges are different. So here the deck completely suspended with the help of a tension members over here. Okay. So these members we called as a cable strungs, right? And these vertical pylons are called as stanchions. Okay, so the made up of high tensile steel cable strands in the form of a centenary to which the deck is attached by steel suspenders, which are made up of steel rods or members or cables. So that is how your bridge was supported. So the bridge which was there in our Hyderabad, which was recently constructed at um, what is that? So there's a place near Inorbit Mall, Durgam Cheru. So it is not a suspension bridge, it is a cable stayed bridge. Okay. So there is a difference between cable stayed bridge and suspension bridge. So basically this suspension bridge can be with the help of a timber or concrete steel also can be used. So where the load transmission takes place to the suspenders. Okay. And see how the forces are transformed from stanchions to cable, from cable to strungs, from strungs to deck. Okay, so see you can all observe here. Every strung is subjected to tension, and even the major cable is also under tension. Your stanchion is subjected to compression, and your anchorage are also subjected to tension. So you can see lot of elements here, they're all subjected to tension. Only the vertical pillar is subjected to compression, right? So even you should know the load transformation in the bridges, right? So the other picture where is focusing. Yeah. So this is what the cable stayed bridge. So I think that this is the bridge which was there in our Hyderabad, which was recently constructed by L&T. So cable stayed bridges also looks like suspension bridges, but the difference is the way how it was, supported. Okay, based on that, your cable stayed bridges are big different than suspension bridges. Okay, so your less cable is required and the towers holding the cables are proportionately equal. So in suspension bridges, you required more cables to suspend the deck. But in cable stayed bridges, limited cables are enough to suspend the bridge. And even it can accommodate the long spans in and around 100 meters to 200 meters of span. Right. So this is an example of the suspension, cable stayed bridge. Looks like. And next one is cantilever bridge. A cantilever is a bridge which is built using cantilevers, the structure that project horizontally into space supported on only one end. See, as we know, cantilever always having a maximum bending moment and shear force towards the support. So by that, your section also should be more towards the support. In that way, you can see. So this is the support location. At this support, the section was too high, and towards center, the section was too low. So where one end is fixed, the other end is free at center, and this is the fixed support, and that center it is a free. Okay, this is how the cantilever bridges have a functionality. Guys, I request to please mute your audio. few of unmuted their audio. So it is getting disturbed, right? So the practical example of a cantilever bridge over here. So you can see this is a fixed support and this is the free end, right? And the fixed support and free end. And this is the suspended span. See how this suspended span is suspended with the help of the cantilever arm. This is your cantilever arm, right? So it always towards support, your section always will be more. Why? Because so that is the portion where member transfers loads to its support. Okay, that you need to understand. And this is the anchorage arm, so which is anchorating in the sense which is supporting this cantilever action. Okay, you can see even the arch bridge, it's steel arch bridge. Okay, earlier you have seen masonry arch bridge. So here it is a steel arch bridge. So still students are joining now. And see how the forces transfers into like it's a movable bridge. So where this support was connected with the help of a pin. So pin usually allows rotation. You will have a resistance towards vertical movement, resistance towards horizontal movement, but it can allow rotation. In that way, movable bridges are basically used for pedestrian walks and for boats or barrages to cross it. Okay, so there the use is the movable bridges. So the movement is basically to allow these boats or bags, for the passage. So this is the practical picture how the bridge is opening with the help of the pin support. Okay, it is in Panama Canal. Yeah. So beam or girder bridge. So it's a cantilever bridge, suspension bridge. Again, different types of bridges. Okay, as I told you, bridges are basically classified based on the span, based on the length, based on the spacing, based on the materials, based on the condition, site conditions, based on the construction of speed, based on the aesthetical look, based on the cost, and based on the maintenance. So these are the considerations before if you want to place a bridge over there, right? And the bridge design process, it takes place from project to scope. So the scope always defines you for what you are constructing a bridge over there. Okay, which talks about functionality, which talks about who is going to be used that bridge. If for road transport, are you using this bridge, or for railways, or for pedestrian walks, or for what? So based on the usage, your bridges are basically classified. That talks about the scope. And then location of survey. So there is a recognition survey takes place before construction of any bridge, which comes under land surveys and all. And then geological information also is very important before you start. Designing the bridge. And the preliminary designs also takes place, and many decisions come into picture. And the project funding and scope finalization is also very important. Either it comes for BOT projects, build, operate, transfer, లేకపోతే PPE projects, public-private partnership projects, లేకపోతే BOQ projects, bill of quantities, based on the funding type, the projects are also classified. Again, the final design, which gives complete specifications, estimations, and plans of the bridges, and then we will go for the construction. This is the bridge design process takes place, starts before and till the completion of the construction. Okay, so that is how your preliminary information to know best about you know bridges. So here there is a poll question. So I request the students, so please answer this question. Which do you think is the greatest modern structure? See, out of the listed one, I would like to put a question to you guys. So out of these four structures like Eiffel Tower, Brooklyn Bridge, Switzerland, Cycle Tobernable Bridge, and Burj Khalifa in Dubai. So, which is the greatest modern structure you consider? So, I'm not just talking about a great structure. I'm asking you greatest modern structure. You can answer me this question in your comment box. So, by that I can just you know look into it, right? So, I want the fast responses, guys. So, which do you think is the greatest modern structure? Guys, are you answering? So put in your comment box. So by that I can see all of your answers. So, okay, altogether 27 participants are in live. Okay, good, good. Eiffel Bridge, Brooklyn Bridge, Switzerland Bridge, or Burj Khalifa. Yeah, people are answering. Burj Khalifa is the modern bridge, modern structure. Okay, good. So I'm unable to hear your voice. So is it audible to everyone, guys? Is that only problem with you didn't write your name? It is XT1562. Is it audible to everyone, guys?
Yes, sir.
Yes. Okay. So I think you have a problem in your voice. I mean, in your system. So please correct it. Okay. Right. Okay. You are answering good. So answer them. So by that we'll continue and finish it soon. And right. So let's see the answer. So here, the modern construction bridge is Brooklyn Bridge, which is opened in 1883, is one of the oldest hybrid cable-stayed suspension bridge in the US. Okay, why I'm telling this as a modern structure? See, modern structure in the sense, so you see, in all your perspective, modern structure in the sense, మీ అందరూ ఏం ఆలోచించారు చెప్పండి? మోడర్న్ స్ట్రక్చర్ అంటే రీసెంట్ గా కన్స్ట్రక్షన్ జరిగిన స్ట్రక్చర్ ని మీరు మోడర్న్ స్ట్రక్చర్ గా ట్రీట్ చేశారు. బట్ ఇన్ మై పాయింట్ ఆఫ్ వ్యూ, modern structure in the sense the structure which is still under functioning, which was constructed many years ago. In 1883 it was constructed. Still this bridge was under under usage. So which is the oldest hybrid cable stayed bridge and suspension bridge. So in my point of view, modern structures are the ones who are constructed many years ago and still which they are in function. Okay. So by that, the Brooklyn Bridge is the modern structure which is still in usage. Uh, okay, in USA. So I think many of you got confused. So because that is my perspective, guys. So because Burj Khalifa, which was constructed just 10 years ago, right? But see the bridges which were constructed even 100 years ago, still they are in usage. We should treat them as a modern. Okay. So which is big challenges to our design engineers nowadays. Okay, and the other question. So I think it's a poll question based on understanding. Let me see that. Guys, you can answer this question also. So by that it will be bit encouraging to us, and we can improve a lot based on your understanding. Rate your current level of understanding of the topic. So I'm already an expert on this. I remember quite a bit about this. I can remember a little bit about this. And what are we even talking about right now? This is new to me. So what you're feeling? So this information on these bridges, do you think it's already known to you, or the information which I shared to you, which is unknown to you? Okay, you can answer any one of these. Okay, in your comment box. So by that I can go through and I just um, try to get more information which few people doesn't know. Okay, so you can answer this question as well, parallel. The options are already an expert on this. I remember quite a bit about this. I can remember a little bit about this. And what are we even talking about right now? This is a new to me, right? Okay. And so there are a few more slides, so which are talking about different again construction processes and how they are going to be constructed and how environmental people are playing a vital role in terms of designing the structures and all, right? So that is how all different structures are located here. So I will share you this PPT where you can have a bit information about the bridge, and the construction takes place with a lot of parameters like cost, constructability. Okay, so based upon the function, based upon the proportion, harmony of the structure, based on the fastness of the structure. Okay, this is all going to be comes into picture. Okay, so just guys, I would like to share this PPT to you. Okay, but our major role is to complete our syllabus within the time. So when we come to the next presentation, definitely I will come up with topics in your skill structures where we finish our fourth and fifth module with within the time, right? I hope this is the first interaction where um, you know it's a better opportunity to share this information to you guys. So in the meantime, I would like to share a lot of videos based on the forensic engineering, based on the plastic analysis and elastic analysis of the structural designs also, right? Yeah, that's it, guys. So this is the ends up with the presentation. Uh, let's see. I mean, we all are going to meet again in the next week based on the timetable given by our coordinators, right? Anything you would like to share to me? So because my schedule was already started for the next session, it was 10:30 to 12:30. So yeah, it's 2 minutes time to you guys. Any questions you can ask me by unmuting your audio. Altogether, there are 24 participants. I don't know what happened to others. And guys, anything else? Anything else you want to speak to me? Mithun? Okay then, fine. Yeah. So that ends with today's class. So we'll see tomorrow then. Yeah. Bye guys. Mithun?
Okay. Sir.
Yeah, fine. Huh?
Okay, sir.
Okay, let's meet in the next week then. Okay. So now I will start
Sir,
with the
PPT.
skill structures. If you want, you can join for that as well. Okay.
Sir, PPT share చేయండి sir.
Yeah, I will share you. I will share you. Okay.
Thank you, sir.
Right. Okay. Now I will come to Facebook Live, where I'm going to start attention members to other participants, those who are there in Facebook Live. Okay. Right. See you guys then. Bye.
Okay, sir.
Thank you.